Hello everybody, a warm welcome to our UltraCam Merlin 4.1 webinar. The speakers of today will be Bernhard Schachinger, Senior Application Specialist Marc Muick, Project Lead and Application Specialist, and myself, Alexander Wiechert, CEO of Vexcel Imaging. If you have questions during the webinar, please be so kind and type them into the Q&A pane of the software, and we are happy to answer them towards the end of this webinar. In autumn of last year, we expanded our product portfolio significantly. Vexcel is well known since many years as the leading supplier of premium camera systems like the Eagle, the Condor and the Osprey aerial cameras, which are all based on the sophisticated punch sharpening concept. In autumn last year, we added the UltraCam Merlin to our product offering. The UltraCam Merlin is a family of cameras, and these cameras are all based on high-end biopattern sensors. And also in addition, we added the UltraCam Dragon. The UltraCam Dragon is a hybrid sensor system combining the power of imagery and LiDAR in one integrated hybrid sensor. This webinar is now all about the UltraCam Merlin 4.1. The UltraCam Merlin currently comes in two different configurations. We have the UltraCam Merlin 2010. That is a camera system designed to serve small to mid-size projects. And then we have the Merlin 3020, which is a camera system designed to serve mid-size to large-size projects. The UltraCam Merlin is setting the standard in the biopattern-based camera market because of its superior hardware, its superior camera design, its superior software workflow, and the well-known superior Vexcel ecosystem. Choosing the right aerial camera that best fits your business needs is not an easy task today. The range of options is vast, and even our own product portfolio has significantly expanded over the years, especially with the recent releases of last year. The market is filled with big promises from various players, often presenting conflicting information. It is completely understandable then that you as a customer find it increasingly challenging to select the right camera. Which is why in this webinar we are taking a new approach. Instead of simply presenting facts and features of the UltraCam Merlin, we've developed a specialized checklist that covers 10 key aspects by which an aerial camera can be evaluated. This tool is designed not only to highlight the distinctive features and capabilities of the Merlin 4.1, but also to facilitate an easier and more effective comparison with other systems on the market. Our goal is to empower you as the aerial survey companies and end users with a clearer and more comprehensive understanding, helping you make an informed decision that best suits your needs. We've organized the checklist into three primary categories. First, factors contributing to image quality. This section addresses the question, how good is the data from the system? It delves into the aspects that determine the clarity, accuracy and overall quality of the images and data captured by the UltraCam Merlin. Second, factors for efficiency. This part of the checklist examines the collection efficiency and resources optimization, providing insights into the long-term economic benefits of the UltraCam Merlin. Third, factor for sustainability. The final category assesses how future-proof your investment is. We understand that technology evolves rapidly, and it is important to know how the UltraCam Merlin adapts to future advancements and changing market demands, ensuring the longevity and relevance of your investment. The first category is about image quality. Marc, it's your time to shine.
Thank you, Alexander. Okay, let's jump into the 5 image quality checklist points. Let's take a look at the image sensors that we use. The UltraCam Merlin, similar to comparable aerial camera systems in the market, employs the 150 megapixel CMOS sensors from Sony. So in this single aspect, there's effectively no difference to other systems. If you're interested in delving deeper into the precise differences between panchromatic and Bayer pattern sensors, there is a detailed paper on our website that provides intensive information on this topic. What is the most efficient system approach for me? Consider this key question. Do you need the exceptional qualities of a panchromatic based system, or would a Bayer pattern based concept better suit your needs? In our premium UltraCam line, we use an additional panchromatic sensor to further enhance the image quality. The color information is added through separate color cones in the UltraCam Eagle or via Bayer pattern in the UltraCam Osprey and the UltraCam Condor. However, it is important to note that aside from the UltraCam Premium line, all current aerial camera systems in the market today, including the UltraCam Merlin 4.1, are based on the Bayer pattern sensors. They do not have panchromatic sensors. This is crucial information for fair comparison, ensuring you are comparing apples with apples. How is motion compensation handled? There are several hardware-based solutions on the market. All of them are falling short on multidirectional, image scale dependent, and scene-aware motion blur compensation. We are using a different approach. We are using a software-based solution called AMC, the Adaptive Motion Compensation, which corrects for all types of motion blur, regardless of direction, image scale, and scenery. Let me show you how AMC works. It all starts with a blurry image. In order to compensate this blur, we need to have information about the orientation data, so GNSS and IMU data. We need information about the scenery itself based on an external digital elevation model and the camera orientation, as well as precise exposure information from the UltraCam. With this information, we can compute the point spread functions that are needed to solve the image blur problem. And that leads to the absolute stunning imagery that our UltraCams create on a daily basis. So the benefits of AMC are quite obvious. It corrects for multi-directional motion blur, considers image scale variations in oblique imagery, can handle scene-specific motion blur variation, and eliminates mechanical parts that are prone to wear and tear. If you're interested in learning more about AMC, I encourage you to visit our website and check out the AMC papers available there. Or feel free to reach out to us. We are always happy to answer any questions you might have. What is the camera design? Are all the lenses nadir? Or are they tilted? If tilted, by how much? The UltraCam Merlin delivers true nadir imagery at industry-leading geometry without tilted camera cones. So for the UltraCam Merlin 3020, 3 sensors are capturing the true nadir imagery without tilt. That means that the image plane and the ground is always parallel, and therefore produces consistent scale of GSD all over the image. That results in a GSD that is the same for the image center and the corners of the imagery. Let's have a look at an arrangement with 2 tilted cones. If cones are tilted, that means that also the focal plane of the single cone is tilted, and that creates an inconsistency in the GSD scale across the image. Or simply put, the center of the image has the planned resolution, whereas the outskirts of the imagery are suffering from warped pixels, which can reach a magnitude of roughly 30%. So to wrap up, the influence of the camera design itself is very important in terms of what the GSD distribution looks like. With a true nadir camera concept like we use in the UltraCam Merlin, we can achieve a consistent GSD all over the image, which is not the case if you use a tilted approach. How are the images processed? Our approach with the true pixel processing, DPP, is a holistic one, meaning that we're trying to preserve all the pixel information from the initial exposure to the final data product. DPP reduces noise in bright and shaded areas while retaining fine details for maximum information retention. The resulting image accurately represents the captured scene with high dynamics, sharpness, and clarity. All our efforts combined, the CMOS sensor, the system approach, motion compensation, camera and lens design, and processing with DPP, they all aim for best-in-class image performance. So what should you as a customer be looking out for? How can you meaningfully compare image quality? Let's explore some key characteristics using example images to demonstrate. Before we dive in, a few points to note. For our demonstration, we have chosen an image section located towards the edge of the frame. This is something we recommend to our customers as well. Typically, image quality decreases towards the edges. To clearly see the differences, we suggest looking at these areas at a high magnification. The level of zoom you use will depend on your screen resolution. For example, I use a 27-inch 4K monitor, and in such cases I zoom in at least 400% to really get into the details. So what should you as a customer be looking out for? Is the image sharp, both in the center and at the edges? How much noise is visible in homogeneous surfaces and how good are fine structures retained? And image dynamic, capturing details in bright as well as shaded areas. For this comparison, we have chosen an image from the UltraCam Merlin 4.1. In this case, a color infrared image. You can see that we have selected an area in the center of the image as well as in the outskirts of the image. Towards the edges, it is always important to have a similar type of resolution target. Therefore, we have chosen another corrugated roof that features the same level of detail and the same structures. As you can see, the quality level does not change towards the edges. The resolution performance is consistent all over the frame. For the next examples, I want to note that those are intentionally over-exaggerated for illustration purposes. The scenery is very interesting. We have a homogeneous surface in the center, the parking lot that enables us quite easily to see any noise that is in the image. We have a shaded area on the right-hand side and a bright lit facade on the left-hand side, so also image dynamic is covered here. Furthermore, also very fine details are featured in this part of the image. For this first example of a legacy processing result, I have added some noise to the image in order for you to see what a real noisy image looks like. So the noise level of an image is highly correlated to the camera settings used during exposure. A fast exposure requires a high ISO setting and therefore results in a higher noise level in the image. Talking about noise, the perception of noise is very important. The perception of noise differs quite a bit if you see it on a homogeneous surface or on fine structures like trees, for example. On the fine structures, noise is more or less creating a kind of artificial resolution that is not really in the imagery. On the homogeneous surface, on the other hand, noise is really disturbing your perception. When dealing with higher noise levels, it is very important to not over-denoise the image. Over-denoising an image results in a kind of watercolory look that is not very pleasant to the eye in the first place, and in the second place is more or less completely destroying all the fine details in the image. Even though image resolution can be improved using sharpening algorithms, one has to be very careful to not overdo this step as well. Especially high contrast edges, like on shadows for example, suffer from over-sharpening. This results in white over-sharpening artifacts. So if we take a look now on the results that were created with our true pixel processing, we can see quite a difference, and especially in the noise level of the imagery. While homogeneous surfaces are basically free of noise, we can still see that the fine details in all the vegetation is still perfectly there and retained. TPP, our true pixel processing, is the ideal foundation for anyone looking to customize their visual content. Whether the objective is to craft an image with stunning visual appeal, characterized by acute sharpness and high contrast, or to create a balanced and clean exposure with well-lit shadows. TPP offers the versatility necessary to fine-tune aerial imagery exactly the way your customers want them. Are you eager to check out the data firsthand? Sample data from the UltraCam Merlin 4.1 is now available. Don't hesitate to contact us and experience the image performance of the UltraCam Merlin 4.1 for yourself. I hope I have provided good insights into the essential aspects of image quality. Next, we will take a look at the efficiency aspects of an aerial camera. Alexander, the stage is yours.
Now let's talk about efficiency. The point I want to address is the footprint of the system. There are two UltraCam Merlin models available. The 2010 serves local projects, boasting 2 RGB and 1 near-infrared nadir sensor. enabling image capture with dimensions exceeding 20,000 by 14,000 pixels. For larger projects, the recommended choice is the 3020 model, equipped with 3 RGB and 2 near-infrared sensors, significantly expanding the strip width to over 31,000 pixels. However, it is important to note that not every footprint is appropriate for all types of photogrammetric evaluations. That's why it pays to also consider the base-to-height ratio in these systems. The ratio is crucial for ensuring enough image overlap and stereoscopic coverage, which are key for creating accurate and detailed 3D models of the terrain. For instance, with a 60% image overlap, the Merlin 2010 models with an 80 mm focal length has a base-to-height ratio of 1 to 3.7. This is comparable to our well-known UltraCam Eagle. For the 3020 model with a 120 mm focal length at the same 60% overlap, the base-to-height ratio is 1 to 5.6, a value still acceptable for photogrammetric processing. In both cases, the image format and the resulting base-to-height ratio are well balanced. When dealing with a footprint that is very wide but short in length, the base-to-height ratio becomes imbalanced. This imbalance can lead to disadvantages in the photogrammetric evaluation. It's crucial to have a well-proportioned base-to-height ratio for the most effective and most accurate photogrammetric outcomes. The next point I want to talk about are the basic camera specifications. The Merlin condenses high performance in a very small form factor. The cylinder diameter is designed in a way that it fits into the existing environment, like all the existing mounts, Ultra Mount 3000, 4000 for example. Weight is a consideration, and we have optimized on the weight to make it as less heavy as possible. Also, power consumption has been addressed so that the system consumes as less power as possible. And especially if you look on the form factor of the housing, the Merlin comes in the same form factor like all the other well-known UltraCams like the Eagle, Condor and Osprey, with this very specific format of the camera head, which allows to mount the camera in a vast majority of planes, even in planes where the mounting hole is outside of the center of the plane, located more towards the body of the airframe. Very important is also how effectively a system can generate business for you as the user. When discussing the efficiency of an aerial camera, the focus typically shifts to aspects like the swath width and the frame rate. We already talked about how big the frame of the Merlin is. With respect to the frame rate, the Merlin is pretty fast. We are talking about a frame rate of 1 frame per every 0.7 seconds. However, beyond the ability to rapidly cover large areas, there are other crucial factors to consider. Operational efficiency. How much time does the camera really generate business for you in the air? And linked to that, in case of an issue, how quickly can support be provided? When you buy an UltraCam, you're never alone. At Vexcel, clients have immediate access to globally recognized experts ready to offer swift support and consulting, whether on-site or remotely. Another key aspect of efficiency is the processing workflow. For that, I would like to hand over to Bernhard Schachinger, our UltraMed expert.
Thank you, Alexander. So what does the entire workflow for data processing look like? Is it a combined high-performance workflow, or is there a need to switch tools during the process? So basically, the software for our workflow consists of 2 components. So first, there's the software that runs on the camera. That is the COS, the camera operating software. And this software provides all the functionality that you need to capture the data. So that COS is very similar for all our camera models and for the camera generations. And then we have UltraMap, which provides 5 modules to process the raw data and then generate all the products which can be derived from the imagery. The UltraMap workflow starts with the first module, which is UltraMap Essentials. This allows you to do the post-processing of the raw data, the level 0 data, to generate level 2 data. These level 2 files can then be used in the UltraMap workflow for all further processing steps. And this does also include to almost automatically set up the project, including all the project parameters like camera calibration and so on. The next step in the workflow, the next module, is then UltraMap AT. In that module, type points are extracted automatically from the images, ground control points can be measured, and GPS data can be integrated. All of that is then combined in the bundle adjustment. The result of that are refined exterior orientations for the images. Then the next step is the dense matcher, where dense image matching is being processed, and that results into a digital surface model, a DSM. That DSM can then be filtered automatically by the software to create the DTM. And then in the next module, in the auto pipeline, based on the DSM and the DTM, the user can then create auto mosaics. So that results on the one hand in the DSM ortho, a true ortho, where no facades, no building lane is visible. And the other hand, the DTM-based orthophoto, which is the traditional orthophoto. And finally, there is the last module in the workflow that is 3D, which allows to process 3D point clouds and a 3D mesh from all the images. That works for nadir images only, like we have for the Merlin, but this also works for nadir and oblique images, like we have for the Osprey. So we have one workflow for all UltraCams. And this workflow is in one application, that is UltraMap Studio. And one project file is needed to do all these processing steps. So that simplifies the interaction for the user with the data. So we have an all-in-one solution for any photogrammetric project. So how does the UltraMap workflow for the Merlin work without the pan channel? So first and most important, the user experience for the RGB-based data, the Merlin data, is the same as for any pan-based data, so like an eagle. And the adaptation of different image types is happening under the hood, so internally in the software, and not by the user in the data handling. So let's have a look at the single steps in the workflow to see where some changes are done to the processing automatically. So first there's the error triangulation stage, and the type point extraction and the ground control point measurement are done for our premium line cameras, the pan-based cameras, usually on the high resolution pan channel. For the Merlin, this pan channel is not available, so therefore the software is creating automatically an intensity image which is derived from the RGB channels. This intensity image is used for the type point extraction and the ground control point measurement. The intensity image is created fully automatically, so the user does not need to worry about that. The next step in the processing, the color balancing, that is not really changed by the pan channel, which does not exist. So this is fully based on RGB, and therefore there are no changes. Then for exporting the single images to TIFF, so the level 3 export, there is now one change, and that is in the resolution of the images that can be exported. Our premium line cameras offer pan sharpening, and for the Merlin this is not available because there is no pan, of course. Then the next step in the workflow, dense image matching. That is using again the intensity image which is derived from RGB, same like in the error triangulation stage. So based on that DSM, then the filtering to the DTM is done. And this filtering is working exactly the same like for our other cameras, because the filtering, which is based on land cover classification, is using RGB and near infrared and not depending on pan. Also for the orthos, for DSM ortho and DTM ortho, there are no changes because of the missing pan, because these depend on products which are generated in earlier stages. And finally, for 3D, the software is using again the intensity image, which is derived from RGB, for doing the dense image matching. So how does the data from the UltraCam Merlin 4.1 look like? I would like to show you through the following screen recording. So here we see a subset of one of the first test flights with the UltraCam Merlin, captured at the beginning of January. So these are just 4 short flight lines in north-south direction, captured with a GSD of 5 centimeters. So let's have a look at the images. Here we see that there is no snow in that area, but as it is winter time, the vegetation is not green, but very brown, and the shadow areas are quite large. The data was captured with an overlap of 80% forward and 60% sideward. So let's have a look at the aero triangulation stage. This view of the data looks exactly the same for this data here of the Merlin, of a camera of the fundamental line, like if we would have data from the premium line, like an Eagle. So even that there is no panchromatic image channel available, the user interface and the ways for how to interact with the data are consistent across all our cameras. As discussed before, the workflow for the Merlin is using an image, an intensity image, which is derived from the RGB channels to extract all the type points and to allow the ground control point measurement. So let's have a look at such image here. So here for the selected image, we see the image projected down to the surface. So actually that is still an RGB image, but when we activate the measurement mode for one of the GCPs, then we see that this is looking like a panchromatic image. And that is now indeed this intensity image, which is derived from the RGB channels. This intensity image is used fully automatically in the workflow. So there is no need for the user to change anything to be able to use data from the Merlin. We have done a number of test flights and thoroughly evaluated all of these in the aero triangulation process by using a lot of ground control points. So for example, for this dataset, let's have a look at the aero triangulation report, where we will see very pleasing results. So here are some numbers that we get out of this little block, with residuals for ground control points and GPS, for example. So let's get on in the workflow to the next stage, so which is the water handling stage. So this project area does not contain a lot of water, so therefore this is a step which we can skip in this case, but just for your interest, I show you here the water mask, which was derived automatically by the software. But as these water bodies are so small, we do not really need to take special care of these water bodies in processing. Let's continue directly to the stage of color balancing and radiometric adjustment of the images. So here we see this block after the radiometric adjustment of the images, including the color balancing. So all the images of adjacent flight lines, they have been made homogeneous automatically by the software. Let's add a little bit of gamma to this block to make the images a little bit brighter. So adding some brightness to these dull winter conditions. There are a number of more tools available, like the curves tools, levels adjustment, and so on, which can also be used to modify the radiometric characteristics of these images. So after modifying the radiometry of these images and adjusting to your needs, you can then export the images. And here there is another little difference to the cameras from our premium line. There is now, for the pyramid level that you can select for the export, no difference in the pixel count for the highest pyramid level and then the high resolution. So here, as we do not have a panchromatic image channel, we cannot do the pan sharpening. Therefore, those two export options here are exactly the same. Following the adjustment of the full image block, we can also work with the single images. So each of these can be fine-tuned. So here, of course, we do have only RGB data available, and optionally there's also near infrared. But there is no panchromatic image channel. The panchromatic image channel is not really needed for the color balancing or for the radiometric adjustment. So that means there is no difference in the user interface and interaction with the data compared to the cameras of the premium line. Going on in the workflow, we reach then next the ortho stage. So here in the ortho stage, there is first a DSM extracted from the data with dense image matching. Then this DSM is filtered to a DTM. So here, first the DSM, then derived from that there's a DTM. And based on this DSM and DTM, we can calculate orthophotos. The dense image matching is using again here the intensity image, which we have already seen in the error triangulation stage. So RGB are combined to this single intensity image, which is used here. So this DSM is derived fully automatically from the data. The DSM can be edited, of course, if there's need to do so, and then it is used to create the DSM-based orthophoto, the true ortho. This layer here shows the contribution mask to the DSM ortho. So every single color that we see here represents one input image, which is used to be finally combined into the ortho mosaic for the DSM-based orthophoto. So all these single patches of single images, they are needed to fill occluded areas in the final ortho mosaic. Based on the DSM, the software is deriving automatically a DTM, which is then used to create a DTM-based orthophoto. And also here we can see the seam lines, the contribution mask to the final ortho mosaic, where we see now much larger patches of images to be combined into the final mosaic. Needless to say that all of this processing here works on the full 16-bit, which are captured by the camera, and is taking advantage of all the benefits of the UltraMap framework, which is well known from all our other cameras. Due to the absence of the panchromatic image channel, there are some advantages in the processing times compared to other cameras of comparable size when calculating the numbers. However, that comes at the cost of the characteristics of that camera concept discussed earlier in this webinar. That's all from me for now. I will see you shortly in the Q&A session. Alexander, there's still one category left.
Thank you very much, Bernhard. The last point on our checklist covers aspects of sustainability. How flexible am I if my business grows? Our diverse product portfolio covers all applications in the airborne mapping. We are the only ones in the market offering the option to upgrade to panchromatic-based sensor systems. When we think about a successful business partnership, it's all about supporting our customers' growth, both now and in the future. So how do we help our customers scale? Well, for those short-term needs, we've got you covered. You can rent our UltraCam systems and UltraMap processing software. Whether it's specific modules you need or just an extra boost in processing power. This is especially handy during those peak flying times or for particular projects. But what about the long haul? We also offer upgrades for the UltraCam Merlin with the fundamental line or to the premium or integrated line systems. This means you can move up to new products at a pace that feels right for you. We are here to help you grow every step of the way. And with that, we come to the end of our checklist and our webinar presentation. We hope everyone was able to take away something valuable today. To quickly summarize, the UltraCam Merlin as a complete package sets new benchmarks in the widespread market of biopattern systems. It achieves this through superior hardware, a superior system concept, superior processing software, and Vexcel's superior ecosystem. If you've not already done, please be so kind and type your questions into the Q&A pane of the conferencing software. We are looking forward to answer your questions now in the Q&A session.
All right, so there are already a few questions in the Q&A pane. First question is what's the price of the Merlin system? So this largely depends on the configuration, but throwing out very enough numbers. Merlin 2010 starts at about 550, 600,000 euros, but then it's all the question about what you're adding with respect to UltraNav mount, software system. So it varies very much, about a few 100,000 case. So if you please be so kind and contact the Vexcel sales force so that you can get a tailored quote for your needs. So next question is, when explaining the processing difference between the fundamental line and the premium line, you mentioned for the level 3 images, it is a direct export from RGB. I guess in reality, it is a little bit more complex. Could you elaborate on this process and how you assure the geometric quality of the image? Bernhard, I want to hand this question over to you, please.
Yeah, thank you. So with the direct export from RGB, I was referring mainly to the resolution. So the differences that we have shown was for the fundamental line for the Merlin. We are using the RGB channel to capture the data, also export the data, all exactly with the same, because there is no pan for pan sharpening, which is the contrast to the premium line. With the pan sharpening, there is the option to either export the RGB resolution, so low resolution, or high resolution imagery that includes the pan sharpening. So that is a difference, and that difference in mind, this statement was done. And yeah, part of this question here are a few more things. So yes, it's a little bit more complex to export this data, of course. I mean, there are a lot of steps. I can't give all of these details, but as there is also the part of the question regarding geometric quality of the image. So yeah, that is definitely handled. And already at an earlier stage. So when doing the processing from the raw data to the level 2 image data, then basically image geometry is taken care of with a a number of components, including, for example, camera calibration, flight altitude, temperatures, and so on.
Thank you, Bernhard. How big is the data quality difference between the Merlin and the Eagle? Okay, fair question. Yeah. Bernhard, you want to take a step on that?
Yeah, so many factors are influencing the data quality. So on the one hand, as we have heard, of course, there is the difference in the technology to capture all the imagery. And then on the other hand, the quality is influenced also by the conditions of the flight, by many environmental factors. So for a fair comparison, of course, the ideal situation would be to have a simultaneous data capture, which is not always possible. So therefore, if there are flights at different times, then we need to consider the different characteristics of the systems to be able to do a fair comparison of the data quality.
Yeah, but at the end, it's fair to state that there are differences visible. So there is a reason why we have this two different camera lineups and labeling them premium and fundamental. So each camera is setting the bar in the respective camera segment. The Eagles, Osprey, and Condors are setting the standard in the premium camera lineup, whilst the Merlin is setting the standard in the biopattern-based camera lineup. But there is a difference in between.
Right.
If you want to delve deeper into the details of the image quality differences or the sensor technology differences, we got a scientific paper out that deals with these differences. Maybe worth a read.
Does AMC and TTP work with earlier camera models? Marc Bernhard, who wants to take that question?
Marc, you want to answer?
Yeah, I think I'll gonna take that one. Thank you. So AMC and DBP will not work with earlier models. So if you're flying an UltraCam Eagle M3, for example, or anything from the third generation, that will not be available, the third generation. That is only available with the fourth gen. So everything that is basically CMOS sensor based, you're working with that principle.
Thank you, Marc. Are there specific applications for which a biopattern sensor is not adequate? Bernhard, you probably wanna take it.
Yeah, I mean, specific applications. Not sure if we could discuss that question with regard to applications, or rather rephrase that a little bit and think about what is the expectation to data quality actually. So as we have heard, there are many characteristics which are inherent to this particular type of technology in comparison to the panchromatic based cameras. So I would rather see it that way for what is the expectation to the image characteristics for the specific application. Then you can choose the right tool for the job.
Well, so in general, that means it's suitable for a wide range of application, but sometimes the underlying technology need to address the system concept. For example, if you're in projects, you might want to fly biopattern with a smaller ground sample distance compared to punch opening to get the same, let's say, visible level of detail in the imagery, something like that.
And also bear in mind that there is a possibility for debayering artifacts to show up. That is something that can occur depending on what the scenario is. And scenario in that case is basically how your pixel grid is orientated towards a repetitive pattern on the ground. And depending if that is set up in the right position, then there might be some interpolation artifact showing up. But on that note, I can also assure you that we have put great emphasis on really focusing while developing the TPP, the true pixel processing, in a way that it deals with this kind of problems while the Bayer pattern image is generated, and not like other systems or software packages are doing, trying to fix that in the post-processing. It rather the trick is to try to not let them grow up or show up in the first place.
Right.
Yeah.
Thank you, guys.
Right.
Yeah.
And to absolutely be sure, there are no such artifacts from debayering process. There's the choice then for the panchromatic-based camera, of course.
Thank you, guys. With respect to debayering, do other Bayer pattern-based sensors require demosaicing? And if so, how is the Merlin different / better? Yeah, well,
if you guys
it's
want,
clear.
then
Bayer
I can.
pattern. Yeah, okay, Marc, take it. Yeah.
I can take that one. So if you're using a Bayer pattern sensor, it has to be going through that demosaicing or debayering step. So there is no difference to other ones. As I said, what were the Merlin, or basically the software excels, is really having that holistic approach that we use in TPP to have everything in one place when we do that. And this is where we can then produce a really high quality image that way.
Correct. So debayering is part of the Bayer pattern technology. It's not specific to the Merlin.
Exactly.
Yeah. In some countries, the images must be masked by the military. Pixels inside the military polygons must be degraded, blurred, and so on. In case we have received the military masking polygon as 3D vectors, can we use them as a mask to blur the oblique images during the image processing in UltraMap? Bernhard, you want to grab that?
Yeah, very good question, very important topic. So we do have integrated some tools within the UltraMap workflow to modify image content for certain regions. So there is some built-in functionality, and we offer a workflow that allows to use some external tools, because very often for that use case, certified software needs to be used. Maybe also that needs to be done by certified persons from military or any organizations. So that case, the data can be taken out of UltraMap. All this modification of image content can then be done in this external software, and then the data can be brought back into the UltraMap workflow. And from that point on, then all the data has this blurring or this solid color or artificial texture or whatever. So that's fully flexible. So this is a workflow which we try to design to be as open as possible, to allow interaction with any of these software tools that are available to do that, and also to provide a workflow which is robust enough to handle all kind of image modifications which are done to these critical areas.
So with this, I wanna close the webinar, and I'm looking forward to see you all again soon. Thanks again for your attention. Bye bye.